Hi everybody, it's Mrs. Foskett again. This is part 2 of the videos for chapter 2 for AP Chemistry. I decided to break the second video down into 3 parts just because it tends to get a little long and I don't want anybody falling asleep when I don't have the opportunity to wake you up. So enjoy the video, take good notes, any questions, ask me in class. All right, welcome back. This is part 2 of our lecture on chapter 2. We're going to pick up with the topic of isotopes. Now, sometimes there's so many similar terms in chemistry that people get them confused. And I know you guys have had this before, but I do want to go over it to make sure that everyone remembers what all these terms are. So an isotope. So an isotope are when you have atoms of the same substance, so they have the same number of protons, but they have different number of neutrons. So the thing is, they have really completely identical chemical properties because the chemistry that happens with any element is really due to the electrons. When we think about whether something will interact or react with another substance, it is due to the activity of the electrons. So the proton and neutron number don't really affect the overall chemistry. And for most things in nature, each element is a mixture of isotopes. So if you remember back when we look at the periodic table, when we look at the average atomic mass of a substance, the reason that that's not a whole number is because it's a weighted mass based on the percent of the different isotopes. All right, so here's just a little graphic to kind of show you about 2 isotopes of sodium. So our first isotope of sodium is going to have 11 protons in the nucleus because that's sodium. And our second isotope of sodium has 11 protons because remember, isotopes, they have to have the same number of protons. Change the number of protons, you've changed the identity of the substance. But when we compare the number of neutrons, we have 12 neutrons in this isotope, and we have 13 isotopes in the isotope on the right. So when you add these together and you're looking at the mass, this would be a mass of 23. As you can see, that's written down here. And then over here, if we add 11 and 13, this is going to be a mass of 24. So we would refer to this as sodium 23 or sodium 24. So just to review that, remember that when we are looking at those symbols of an element, the X here refers to the element's symbol. So that's going to be our capital letter, lowercase letter combination for each element on the periodic table. And then the upper number is going to be the mass number. And in this case, remember that this is for a specific isotope. So this will be a whole number, not a decimal number. And down here, the Z is the atomic number. All right, so this is sort of our standard way to write an isotope. So remember, we want to find the mass number of this isotope. And so the mass number is going to be based on the number of protons and the number of neutrons. Because remember, electrons don't weigh anything. So if we want to find the mass number of this, it's going to be 23 plus 28. So our mass number should be, there we go, 51. All right, the next question becomes, how do I identify this element? How do I figure out what this is? So if you take out a periodic table and you look at number 23 on the periodic table, because the number on the periodic table refers to the number of protons, if you find number 23, you will find that it is in fact vanadium. Okay, We're going to quickly go through a couple, the two main kinds of chemical bonding. We're going to go through covalent and ionic, and then we're going to do some of the naming review. So remember that a covalent bond is a bond that happens because we have two atoms that are sharing electrons. It results in a collection of atoms called a molecule. Now this word molecule over here, this gets thrown around a lot, but you have to remember, you have to remember that the term molecule itself can really only be used to talk about covalent things. In the case of ionic compounds, they are not molecules, all right? All right, so speaking of ionic compounds, when you have an ionic bond, it's a bond due to the force of attraction between oppositely charged ions. All right, so what's an ion? It's an atom or group of atoms that has a net positive or negative charge. So how did that happen? That means that it must have lost or gained some electrons. And if you remember the terms, we have a cation, that's a positively charged ion, and it lost electrons. And then the other term is an anion. It's a negative ion and it has gained electrons. So if you have trouble remembering the two, I always look at it as this T in cation is kind of like a plus sign, and so that is the positive ion. An anion has the extra N in it, and it is the negative ion. Okay, so let's take what we learned about figuring out the isotope mass number and atomic number and things like that, and add to it the ion idea. So what happens if we have an isotope that it now is positively charged? It has 54 electrons and 78 neutrons. So what is the mass number of this isotope? So now remember, to find the mass number, I need the number of protons plus the number of neutrons. But if I look at this problem, I have an issue. I don't know how many protons it has. It didn't tell me. It says electrons and neutrons. Well, what can I do from this to figure out how many protons it has? Well, it says that this isotope is positively charged when it has 54 electrons. So if I imagine that if this now had 55 electrons, this would then become neutral. And since our number of protons and electrons have to be equal in a neutral atom, we can say that, okay, well then this must have 55 protons. So if we want to figure out the mass number, it's going to be 55 protons plus the 78 neutrons. So that should give us 133. Okay, we're now going to begin a section on the periodic table. And as I've said before, this should all be review for you. Important things that I want you to make sure that you remember are the difference between the metals and the nonmetals. The difference between groups or families and periods. Remember that groups are the ones that are vertical and periods are the ones that are horizontal. Okay, so let's take a look at the periodic table. And this year we're going to be using a slightly different periodic table than we used last year. I will be giving you a copy of the AP test periodic table, and that will be the one that I want you to use this year. So let's just remind you of a few quick things on the periodic table. I'm sure you all remember most of it, but remember we have our families go up and down, our periods go horizontal. Our metals are the majority of the periodic table. We have basically everything from group 1 to 12 and most of 13 here. Remember this stair-step line here? That breaks off our metals from our non-metals, and then we have our few here right around the line that are our metalloids that have some very specific properties. And then on the far right of the periodic table, we have our nonmetals. Don't forget our friends, the halogens and the noble gases. We will go over more of the periodic table in more detail. We will come back to electron configuration, trends of the periodic table. That will be coming up in a future lesson. So we were just talking about ion formation and some bonds. So let's just go over some basic things to help you remember that when we look at the periodic table, remember that it can help us to figure out what the charge on different families are going to be. So if I go back to the periodic table, we're going to look at the alkali metals, the alkali earths, the halogens, and the noble gases. All right, so here's our alkali metals. These are all going to pick up a charge of +1, meaning they lose 1 electron. Our alkaline earth metals, those are going to lose 2 electrons, give us a charge of +2. Then we go all the way onto the other side of the periodic table. We have our noble gases, which have no charge at all. Their shells are completely full. And then we have the halogens with a charge of -1, as they usually pick up 1 electron.